Giving them something they can feel. Because, hey, how's it going? Today we are going to talk about STL Exports on Donnan's Tips and Tricks video series. The goal here is to take something like this, which is a 3D model, and turn it into something like this, which is a 3D printed object. We use the Stratasys U Print Plus, which looks something like that, except there's no way that we could ever make something like that without a whole bunch of support material, but I digress. Let's go ahead and get into it. You see, in order to export out, we need to make sure that our model is prepared. So I'm going to start here with my 3D car. Now, this car looks fine. I built it for a simulator. So it's built in a couple special ways. You'll notice it's got a bunch of extra stuff on it, like collision. So I'm just going to delete this and delete all this collision stuff. So we just get rid of it. Here. If you have collision on there, you want to get rid of it because that's not going to matter. Now, you'll notice that my car is made up of 4 tires and it has bones. Like the whole system is skinned to bones. Now I'm going to want to get rid of those bones. And the problem with my current model is that these don't actually connect to anything, which is basically fine for a car that you're going to be riding in a simulator, but for printing purposes, this will not work for us because we will have huge issues. Basically, when we print this, the wheels will print. There'll be a bunch of support material, which is a type of plastic that melts when we put it into an acid bath. But then once we melt the plastic off, these tires will fall off and float around in the acid. And that it's actually a base. But whatever, the point is they will fall apart. And that's not what we want. So we're going to have to fix all of the problems that we're going to have printing. Now you'll notice in the original picture, let me bring it back up. You notice it's dark green. That was just by accident. It doesn't really matter. Whatever plastic you have in there is what color it's going to be. But since it was dark green, I went ahead and made my image of my 3D model dark green, and then I printed it out. You'll also, you'll also notice, if you look closely, you can see actually each little strip of plastic and how it was made. Now, when we print this out, I usually set it to print overnight because a build like this will take about 8 hours. And on the inside, it's actually quite hollow. It's honeycombed in a way, where the inside is much less dense than you would think. It's strong enough, but it's not extremely durable. So you'll sort of see how that works a little bit later. But first, we need to prepare our model because, like I said before, this was built for me to work with in a simulator. So physically, it doesn't make much sense. So what we need to do first is get rid of the bones and this modifier. I've got a skin modifier on there, so I'm just going to delete that. Now, depending on your model, this may drastically change your model, and then you'll have to adjust it. But for now, that's not going to be a problem. But I do want to get rid of the bones, so I'm going to hit H to bring up my list of objects, and I'm going to look at expanding all that. I'm going to grab all of these, select them, and then delete them. Now, if you don't have bones in your model, then you don't have to worry about that part. You can just skip it. Now we need to run an STL check. It's actually in the modifier list. Just type ST and it should pop up. So you could really just type ST and hit enter. And now what we're going to do is over here in parameters, we're going to check for errors. And we just want to check for everything. And then we're going to select faces and edges and see what shows up. All right, so all you got to do is click check and then wait. So I've got 91 errors. Now it seems like it would be okay, but now that we see there's a bunch of issues. Besides the fact that the wheels are going to fall off, there's other issues. For instance, because I built this, and I'm going to delete this modifier for now. The way I built this object, I'm going to go back into my modifier, go to element, and I'm going to select this section here. Now, if you'll notice, I can isolate this selection here, and sort of see what I'm dealing with, if I lift this up, I don't have any face on the back of it. And that is where we get into real problems with 3D printing. You must have everything enclosed. You cannot have any sort of plane because it will not print properly. Now, luckily, it's pretty easy to fix that, and we don't need to worry about it being perfect. So we can kind of be a little sloppy with it. So I'm going to go to border, which is over here. I'm going to click border, and I'm going to grab this border here, and then I'm just going to cap it. Okay, now, that's not really enough. I should probably go through and make at least a couple of these edges connected so that it knows roughly how these faces should be connected. Right through there, and then go back into element, come up here, and maybe connect this bottom one here, right there. Connect, boom. Now you'll see that it's kind of got a face to it. You know, it's not perfect. It's still an n-gon, but mostly the 3D printer doesn't care about n-gons. It will figure out on its own what way to print it. So I'm going to set that back down in there, roughly where it was. As long as it's not coming out of the bottom, it doesn't really matter. Okay, so I have a lot of those exact same problems. I know that when I created the element dashboard, I did the same thing. I created the dashboard like this. It's like a separate piece. So once again, I grab border, select the entire border, cap it, and then I'm just going to connect a few of these edges. Let me connect that one. Connect. And you can see that it's not very pretty. I really would just want to get the ones that are kind of on the outside. Connect. And connect. And maybe these. Once again, you can see not the UV, but the material is pretty rough. But we don't really care because the material is not going to matter at all once we get it into the engine. So once again, you could sort of connect all of these if you wanted to get really fancy, but mostly I'm just trying to make sure that I've put them back together. All right, now I can put this back. Oops. Grab the element. Grab the whole element, and I'm going to put it right back where I had it. There we go. As long as it's sticking in there, it should be good enough. Yeah, it looks fine. Oh, it's sticking in too far. Oh, wrong thing. And there, good. Cool. Come up to there. I think I had this section sort of set so it looked like it was there. All right. Now I know the seats, I believe, were also the same sort of problem. They're probably hollow on the bottom, which they are. Those are easier to cap because all we got to do is select that and hit cap. Select that and hit cap. Cap is great. You just grab borders and you're good to go. So I grab all those. Left view. Oh yeah, my left is my front. My front is my left because of Unreal prefers left to be rear. It's weird. It's annoying, but it is what it is. So if I hit front, it's giving me left view, which is a pet peeve of mine, but it is what it is. All right, so let's put this back down where it should be. There. Yeah, it's close enough. All right, great. F3 again to get my shaded view back. All right, so once again, you could probably skip through all that section. The point being is you've got to make sure every single one of those holes is capped. Let's see. Let's run an STL check again. Check 26. That's significantly better. It's not perfect, but it's way better. You see we've got an issue here and here. Now, that reminds me, if I hit F3, you can see the wireframe view and you can see where my problems are. The inside of the steering wheel and the back side of the steering wheel console, as well as the inside of the rear view mirrors. So I probably don't even need to move those. I could probably just go back, delete that, go into editable poly, grab border, cap it. Same thing on the other side. Grab the border and cap it. And then the same thing for the inside of the steering wheel section. Cap that. And I think this is also a problem. Cap it. All right, cool. Remember to deselect this stuff before you add the modifier. STL, enter, check. All right, so technically this could print right now. I could set this up, get it printing, and it would sort of work. The body of the car would print just fine. The problem would be is the wheels would fall off. So what we need to do is figure out a way to fix the wheels. The way I'm going to do that is I'm going to delete this again, go to editable poly, and I'm going to take some of this section here, and there, and say, okay, what do I really want to do with this? I could take this and move it down. I could scale it in a little bit, right? There's nothing terrible by doing that. I could undo. I could take this whole section, hit W, move it down more, maybe scale it in some, right? And then move it down some more, because we need to make sure it's a real piece, right? Now, all I need to do is make sure that this piece here, the wheel, actually connects to something. But if I want the wheels to turn, I could actually do that. And on the model that I created as an example for this, I did make sure that they could turn. So what I did is I set all of this and I inset this. I inset it by, whatever, that much. It looks like 18.5, give or take. All right. Actually, I'm probably going to have to go smaller, like 25. I know you can't see that, but trust me, I used the spinner to change the inset amount to 25. So I'm going to inset that by 25, and now I'm going to extrude using the settings. You can see I create a column, and I'm going to extrude that. Hit F3 so you can see it. I'm going to extrude it by pulling the spinner up until it goes all the way across to the other tire. Great. I click OK. F3 again, and you can see it's over here. Now, you'll notice that that means it is going through this face, and that's kind of okay. We've basically said that, okay, this will go through this face, it will go through that face, and as it currently stands, as long as this axle goes all the way through this back side of the tire, it would actually work. Like, the tire wouldn't fall off, and it would be just fine. Realistically, though, if we want this thing to spin, we need to actually build it out with enough space for it to spin. Oops. So I'm going to inset this. And we said 25 is set. Good. I'm actually going to delete that face. And I'm going to hit F3. Come over here. Select this vert right there. Grow it. And then convert to face. Deselect that and delete it. Delete. Okay, cool. Now I can grab this border, F3. Look at it from the front. I mean left, because the left is the front. And now I'm just going to line this up with the tire so it's close. Cool. And now I can actually take all of these edges that are very difficult to see, but grab all of these edges. I have 32 because of course my tire is 16, because I love good numbers like 16. And I'm going to weld via settings. And it says before I have 1722 and after I have 1706, which means I have welded 16 to each other. So F3. So now, it's hard to tell. I'll turn the grid off by hitting G. You can see that it actually connects all the way through. All right, so I've got one tire that goes all the way through, one axle that goes all the way through the other axle. Now, in order for this to work, I still need to make it roll. I need to create like basically like a hole or a cave that we can go through. So I'm going to do the same thing. I'm going to inset, except this time I'm going to inset by just a little bit, F3. 25 is way too big, so I need to inset by, looks like 3. And that makes the same size on both sides, which means it's low enough to be there and still be good. Now, I might have to adjust this some. I'm going to convert this to Vertex. I know you can't see this, but I right click, click Convert to Vertex, and then it allows me to get all of those vertices. I'm going to deselect the ones on the bottom, and I'm going to bring the top ones down, and then I'm going to bring the top ones in. Cool. Same thing here. I know it's kind of difficult to see, but I'm going to grab the bottom ones as well. Because what I'm trying to do is make it so that there's not a whole lot of extra area for the axle to spin around in. There. So from the left view, actually I wonder if I can convert that to, I'm going to try and convert that to face. Yeah, it kind of worked. I'll deselect that one, deselect that one. Oops. I'm not going to get it. I'll have to get underneath. Come on. There we go. Alright, cool. So now if you look from the, once again, my front is weird. But I'm going to line this up and basically try and have it set so it's got just enough space for that axle to actually have some room to roll around in. See that? Now I'm going to delete these polygons just by hitting delete. And what I'm going to do is connect this edge all the way across from the inside. Alright, so this is where it's going to get a little tricky. I think I'm going to grab the axle and move the whole thing out. Actually, let's make a note. Currently on X, I'm at 138.835. 138.835. Okay, I think I remember that. So now what I want to do is connect this, go to edge, and I'm going to connect from there. Oops, I'm going to hold Control and select the two and connect. I probably have to bridge from there to there. Yep, it worked as a bridge. And then from there to there, from there to there. Perfect. All right, cool. So what I've done is now I have an actual hole that goes all the way through. I can always go through and make this front here and here. I can make this a little thicker because I don't want that to fall apart. That would be sad. There. See that? All right, cool. Now I'm going to grab this section here, and I said it was 138, 1.835. Let's see how that looks. I think I remembered. That's pretty cool. All right, great. So that's where that is. Now, rather than redoing all that stuff back here, I'm just going to delete those and then copy this section and move it back. The same process would apply. So I would take this, and since I don't need to worry about it, I'd grab this one and this one. I would, front view weirds me out, inset, and that's fine, and then right click, convert to Vertex, and now I can pull those in. Oh, it didn't work. I forgot to confirm my inset. There we go. Now I got to convert to Vertex. And now I have the ability to do sort of what I wanted to do. Align those. Align that. You don't really have to align this stuff. I'm just getting fancy. Fancy. I'm so fancy. And you don't even know. Alright, good, good, good. Alright, left. I mean front. Oh, it's so annoying. Okay, cool. I'll bring those in and bring those down. Same sort of thing, just to make it stronger. Select those, delete them. So now I got a hole, edge, bridge, from there to there. it should bridge pretty easily. The only problem, I find that if it's not bridging, it's usually because you're trying to connect to an object that you have not welded. So you got to make sure your center line is already welded, that sort of stuff. But generally, bridging, if bridging's not working, it's not an error. It's usually a user problem. So I'm just holding shift and moving this back. Sure, we'll call it whatever. Now the problem is I need to bring these faces down some. Actually, I probably should do that by vertex from the front because I'm crazy. F3. I want to grab that one, that one, that one. I'm trying to get just the vertices that will control where my axle hole is. There. And once again, we might want to make sure this has a little more room. Now, if you want to get really fancy, you'd make sure that these two vertices were level with these two, which you could easily do by holding R and scaling down like that. And same thing with this. These two, or actually those four. Notice I'm getting 4 up here. And these, them being level is really important because the way that axle is going to fall, or where gravity is going to pull this thing down, you're going to want to make sure that that's where that works. So F3. Okay, cool. So now I've got actual axles. I've got actual tires. So now we're actually ready to double check our STL because that's one of the last things we need to do. So hit Q, select our object, STL, enter, check, no errors, perfect. We're finally ready to go. So now to export this thing, you just go to File, and there could be a ton of things in here, and that's kind of okay, but we want to make sure that everything is one object. See how this is all connected to one object? Also be careful that there's no faces that are being problematic like this. I'm going to actually grab this edge and bring it down some. There. Cool. Front. Grab this and pull it up. Grab this and pull it up. Sure. That should be fine. Once again, we were being a little, oh, I don't know, sloppy, I guess. You'd probably want to take more time. Make sure that you don't have problems like, see how my tires there would actually be knocking into stuff. That would be bad. This is also bad. I could probably just maybe scoot these in. I don't know if that's going to print well or not. Anyway, the whole idea is you should probably be careful about what you're building and not be so slapdash. It's a fun word. Anyway, so basically we just want to make sure that we don't have anything intersecting our tire and we don't have anything intersecting with our object. Now, because things like this is its own separate element, but it intersects with this part of the car. So it's going to automatically weld into that car when we print it, and that'll be fine. Anyway, so we have this object. We make sure we don't have any elements or things selected. We go to STL Check. Check again, no errors, good. So here we're going to go up here, and I think you're going to be able to see this. We're going to go to Export, and you just click on Export. You actually don't do anything. I'm going to go to my desktop, and I'm going to change it to stereolithic, or stereolitho.stl. Alright, we'll just call this convertible. Oops. Convertible. Save. Okay, now the object name is going to be whatever. This doesn't really matter, but we're going to go ahead and put convertible. Click OK. And there you go. You've just exported it out. Now, I'm going to minimize this, And you can see on my desktop, I've got this wonderful convertible file that I spelled canovertible. Super. I'm a good speller. If you look closely at this convertible file, it actually, once you have the proper software installed, which is this slicing program we're going to use in a second, once you have that installed, you'll see that it kind of gives you a heads up on what's going to happen. Okay, so now what we're going to do is take this file, this convertible STL file, and put it into our Catalyst EX software. All right, now this is what we use to actually print with. Now you can see it has like a little grid. All I got to do is take this and drag it over. Now, that's way bigger than my space, right? When I built the car, I built it in Unreal units and yada yada. But the point is, it's bigger than my build space, which is 8 inches by 8 inches by 6 inches tall. So I need to change the size. Now, all of this information here is letting you know what the car is going to look like. All right. If there are any sort of errors, it would say that there. It also shows STL units and STL scale. The scale is where we first start messing with it. So I'm going to change it to 25%, so 0.25, and see how that looks. All right, cool. So that's much more manageable. So our car now is about 4.5 inches long. And once again, those are inches, grid inches. So let's say 4.5 inches long and about, what, 2.5 inches tall. That's fine. Now, model interior over here. This actually gives you an idea of what the inside of the model is. High density means it'll be very, very dense and very expensive. Low density means, or sparse, low density, or solid, I'm sorry, means it'll be dense. High density means it will be kind of dense, and low density means it will be mostly honeycomb. The layer resolution can be either 0.01 or 0.013. So 0.01 is actually a smaller, thinner line of plastic. So the higher resolution you want that 0.01 instead of 0.013. All right, now the next thing we do is go into orientation, which is up here. Here, we generally click the Auto Orient button. And what that does is the computer figures out the best way to build that. So it says, okay, the best way to build this to use the least amount of material is the way it currently is. If you wanted to, you could actually flip the car if you wanted to flip it like this. But if you did that, it would have to build up all of this support material underneath. Sometimes you can do things like, this is probably not wise, but if you hit Auto Orient, it generally decides on the best option. Okay. Now, the next thing we have to do is process the STL. So you click Process STL, and what it does is it figures out the tool paths that the robot, like the robot arm, will move as it slowly lays out each individual line of plastic. Now, as it lays out a line of plastic, it has to build on top of something. So that's where you can see that it creates this other layer of what's called support material underneath it. The support material will support things like the inside of the axle and the convertible overhead. Sure, we're going to override it for now. Because I've already done this, it's like, hey, this is already there. Anyway, so the idea is that's what we end up, and this is where we're at. Now, we are going to add to pack, which automatically adds it to our pack, which is our next tab. This is the actual object. You can see I can move it around on the build plate. I usually like to move it in the back because it wipes off the material back here and then it moves more. So this is actually a little faster because the arm has to travel less than if it was over here. So I'm going to put that there. And here's where it says model material 2.58 square inches, support material 1.22 square inches. And then it'll take about 5 hours and 34 minutes to print just this object. Now that's where we go into the sheet. Let's see if I've got it. Dim part estimator. Okay. Now that's where I put in the information. So if you did not make the top on, you just want to print something. This is how we tell. So we're going to do low density. So I just put an X here. I can delete that. All right, and you'll see the change cost. And I have all the standard costs in here. And then what I do is we say 2.5-inch square of model, 2.5 of model material, 2.58 and 1.22. 2.58, 1.22. Okay, and this is what I would print out for you. So to print this car will cost about $18 in plastic. Plus we have to cover the warranty. Consumables are the acid bath, and then I don't charge for labor because I'm a teacher and I'm basically a slave. And then the total profit margin right now is 0, but often I set it to 5%, and then all that money goes to buy more plastic so people can print more stuff. And then we'd print it. Like I said, it would take 5 hours, 5.5 hours to print, and then I would have to put it in the acid bath, which is in the back of the room, for about 12 hours. So you're looking at a 2-day turnaround time for your object. But that's basically it. After that, you'll have your own fancy little car that you'll be able to touch and feel. Pretty cool, huh? So that's the basic layout of how to use the STL format to print on the printer that we have, which is the Stratasys Uprint SE Plus. All right, thanks for watching. I know it's kind of a very specific video today, but I hope this will help, and I hope you get your STLs to me so we can print them off. Thanks again. We'll see you next time.